math lovers. Welcome to notes number 25. I'm on section 1.4. I have one problem for us to look at today. It's from your textbook, page 120. I'm on number 126. It says two planes leave simultaneously from Chicago's O'Hare Airport, one flying due north and the other flying due east. The northbound plane is flying 50 miles per hour faster than the eastbound plane. After 3 hours, the planes are 2,440 miles apart. Find the speed of each plane. Okay, this is a great problem. So what I'm going to do is I'm going to draw the little picture that I have in the textbook. You're always going to draw the picture. It's always important. You know, the first rule when you're working with problem sets is to draw a picture. Okay, so let's see. I'm thinking about it. I've got a north plane and an east plane. And I've got, do I know the rate? No. Do I know the time? Yeah, I do know the time, right? It's 3 hours. All right, I'm thinking I need to organize my data. Let's say I have a north plane and I have an east plane, right? Let's make it clear. I don't know my rate, do I? But I do know my time. My time for both planes is 3 hours. My rate, let's see, the northbound plane is going faster than the other one, right? 50 miles an hour faster. So if I call my east plane, let's call it R for their rate, and the north plane, let's do R plus 50. You know, rate times time is equal to our friend distance. So let's see, that's going to be 3 times R plus 50. And I've got the distance here of the eastbound plane, that's 3R. Oh, awesome. So let's take this and bring it back to our problem. I know the distance from plane to plane is going to be 2,440 miles. All right, we're dealing with miles here. My eastbound plane, hey, that's 3R. And my northbound plane, I already know that distance. That's going to be 3R plus 150. Okay. All right, I got a triangle. It's north and east. It's due east. So I know it's a right triangle. Ooh! Oh, fun, fun, fun. Oh, you know what I can use? Pythagorean theorem. Okay, so if I can find the distance of the eastbound plane and square it, and the distance of the northbound plane and square it, that should be my total distance that they're apart, the 2440, right? This is fabulous. All right, so the eastbound plane is going to be 3R squared. Notice the parentheses. And here I'm going to have the 3R plus 150 squared equals 2,440 squared. Okay, now you guys, you know, I'm not cruel or anything. I am okay with you using a graphing calculator here for all of this. I will have to FOIL this out. So this, I'm going to start over here, which would be 9R squared. I need to FOIL this term. All right, so let's see, that's going to be 9R squared. I have 3R times 150. That's going to be 450R. I'm going to have another 3R. 3R times 450. Another little mistake here. Got my easy tape. There we go. That's going to be another 450R. And then I've got the 150 squared, which is 22,500. Okay. And that's gonna, let's see, equal the 2,440 squared. I need to clean this up first. This is too much before I jump in. All right, so let's see, I've got 18R squared. 18R squared, add these two together, that's 900R. See, I probably should take this over here, don't you think? Yeah, so on your calculator, you're going to put in 2,440, square it, and then take away the 22,500, and that's going to leave me with negative 5,931,100, and that's equal to 0. All right, well, we got an equation. All right, we're good to go. Got an equation. I'm ready to solve it. Factoring that off the top of my head, probably not going to happen, right? So I need to use my quadratic formula. You know exactly. You need to use your quadratic formula. We love our quadratic formula. All right, so in this case, A is equal to 18. You can see that right there. B is equal to 900. and C is equal to negative 5,931,100. All right, so you guys that are programmers, my computer science kids, my kids who love to program, this is the point of the class when I say you should take your 84 and you should Google how to program the quadratic formula into it. We would just pop it on in and we'll be ready to go. That's a great thing to do. So let's go ahead and write this out. Since I did not program my calculator, it would be R is equal to negative B, so negative 900 plus or minus the square root of B squared, so that's 900 squared, minus 4 times A, which is 18, times C, which is this beautiful number here. Oops, can't lose a 0. All over 2A, so 2 times 18. Okay, so this is the point you pull out your handy dandy and you've got negative 900 plus or minus the square root of 810,000 plus, and if I put all that in my calculator, notice that negative times negative is going to give me a positive. That's going to be 427,039,200 all over 36. Okay, so you got a couple options. Go ahead, pop that into your calculator. So that's going to be negative 900 plus or minus about 20,684 all over 36. Now, kids, what you're going to do is, you see you have plus or minus? I'm talking about the speed of a plane, all right? Now, the speed of a plane is not going to be negative. There's no way it's going to be negative, right? We can only go forward. So what I'm really thinking here is, as a math purist, I'm going to think about plus or minus because I'm using the quadratic formula. However, in the context of this problem, I've got to think about the application, and I'm only going to go ahead and I'm going to add those two together. So I'm going to do negative 900 plus 20,684 divided by 36, and that's going to give me approximately 550, and we're talking about miles per hour. Now you've got two planes. If R is equal to about 550 miles per hour, all right, my second plane, which is going to be R plus 50, can you see this all the way down the bottom of my paper? Yeah. It's going to be about 600 miles per hour, okay? Now, does that make sense? Yes. That's a reasonable amount for the speed of our planes. Look at all the beautiful work we did here. We have both rate times time and distance in our problem, and we're using the quadratic formula. Again, if you'd like to program your calculator, your TI-84, totally fine with me. You could do that. That would save you some time when you do have the quite involved problems. All right, good to know. Have a great day. Enjoy your problem set. Have fun.